Hey, what's going on, guys? Let's do this problem right here. The question is asking if you use 10 terms of the series starting from 2 to infinity 1 over n ln n square, how accurate would your estimate be? So let's see how we can do this one. So first of all, before we do this question, we have to make sure whether this one converges, right? To do that, to find that one out, we have to do the integral test. So to do the integral test, we have to know whether it is positive, decreasing, and continuous, right? So let's rewrite this one as a function and see that. So first of all, we are going to have f of x. So let's write everything in terms of x. So here we are going to have 1 over x ln x square, right? And as you see this one, this is going from 2 to infinity. Since the denominator is 2 to infinity, we don't have any number that makes this one discontinuous, so we know that this is continuous. So that satisfies first condition. And the second one, is it positive? Since it's going from 2 to infinity, all the values below are positive, so therefore definitely this is going to be positive. So that satisfies the second condition. And is it decreasing? As you see, when the denominator value increase, the total value will decrease because we are dividing this one by highest number, right? So as the value increase, this value will decrease. So we know that this is decreasing. So we know these three things. So now we can go ahead and do the integral test, right? So let's rewrite this one as an integral. So this is an improper integral, right? So first, this is going from 2 to infinity 1 over, so let's write this one in terms of x. So this one is 1 over x ln x square, and since this is an improper integral, we can write this one as limit t approaches infinity 2 to t, right? And this is going from 2 to t and 1 over x ln x square. So now let's go ahead and integrate this one. So which method we can use to integrate this one? If you notice, we have ln x in the denominator and 1 over x here. So we know that there's a derivative outside, so we can go ahead and do the u substitution. So let's pick u as our ln x. So ln x is going to be our u, and if I find the du, that's going to be 1 over x dx, right? So 1 over x dx, now we can write everything in terms of u. So let's rewrite everything in terms of u. So this is going to be integral, forget about the limits of integration for now, just do the integration and finally we apply the limits of integral. So here we are going to have 1 over x is going to be just 1 over x dx is going to be, so here we have a dx, don't forget that. So we are going to have a dx right here, and 1 over x dx is going to be du. So we are going to have a du right here, and ln x square can be written as 1 over u square, right? This 1 over u square is same as integral u power minus 2 du. So now all we have to do is add 1 more to the power and divide by that power. So if we integrate this one, this is going to be just u power minus 1 divided by minus 1. And then all we have to do is plug the original value, that is u value is ln x, right? So let's go ahead and plug that one. So let's take the limit t approaches infinity, and this is going from, so let's bring the u to the downside because u power minus means 1 over u. So this is going to be, we can write this one as negative 1 over u, right? So let's rewrite this one in that pattern. So 1 over, we plug the u ln x for u. So this is going to be ln x, negative 1 over ln x going from 1 to t, right? That was our limit, it's 2 to t. So that was our limit right here. So 2 to t, let's plug the values. So here we are going to have limit t approaches infinity minus 1 over ln t minus 1 over ln 2, right? Minus 1 over ln 2, and then all we have to do is do the limits. So if we substitute infinity for this t value, what value we are going to get? If you notice that we are dividing this one by 1 by an infinity, that's going to give us 0 right here. So we are going to end up with negative 1 over ln 2, but we have a negative in front of this one, right? Negative 1 over ln 2, that's going to make this one positive. So this is going to be, the answer is going to be positive 1 over ln 2. So this is, since we have a finite number, this converges. So since the improper integral converges, we can go ahead and say this series also converges. So this series also converges. Now now we can go ahead and do the final question. If you use 10 terms of the series, how accurate would your estimate be? So that's the question. So here, if you notice that this starting from 2, right? So 10 terms of series means 2 is starting from 2, so 2 is going to be one of them. 2, 3, 4, 5, 6, so it's going to go until 11, right? That's what we have to be careful. So it's going to be starting from 2 to 11. So what we have to do is, all we have to do is change the limits of integration. So instead of 2, we plug 11. So if we plug 11, what's going to change is this 2 remains the same, right? So only the lower limits is going to change. So finally we will end up with, still we are going to get 0, because ln t is going to remain the same, and still we are going to get 0. Only value that's, this is 11 right here. So only value that's going to change is this 1 over ln 2, that's going to become 1 over ln 12. So our approximate error is going to be like, this is going to be R10, right? So we are going to have error in R10, and if you want to be more accurate, this is going to be 1 over ln 11 to 1 over ln 12. So that's going to be the final answer, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.